Okay, can you see my screen?
Yeah. You can start when you want.
Okay, great. Hi, everybody. Great to be here with you virtually, and I'm excited to present our preliminary studies on what we're calling primitive elimination. And this is joint work with Alexis Kilayko, who was a post-bac research scientist with me at Smith College. So many of you know me and that a major part of my work is focused on the idea that for human cognitive behavior, a significant part of the systems that we have or we can propose for meaning representation, knowledge representation, and reasoning has to be some kind of non-linguistic mental model, mental imagery representation of embodied cognition. And I think very, very well related to the things I've been hearing at the conference that people have been saying about mental imagery and inner language and inner speech. So for me, here you see on the right these non-linguistic or language-free representations. The example there is the Minsky-Schenk conceptual dependency transframes system. They're language-like, but they're very different from the linguistic representations like those on the left. They can map onto one another, but the mappings aren't one-to-one because, as people say, there are many ways of saying the same thing. And we found the best way to do this kind of decoupling between language and non-linguistic representations is to represent the non-linguistic things as decomposed combinations of abstract conceptual primitives, like in this example on the right here, to represent Lisa kicked the ball. A propel is a conceptual primitive meaning something struck or applied a force to something, and move means that an animate entity moved a part of its body. And this is not easy because at every turn you're trying to avoid basically putting words in your representations and structures or using a word to label something that's supposed to be language free. But this is an interesting challenge to us. And a major part of this quest is to try to limit ourselves to a small number of primitives when representing things, because you can get richer mappings between things, between conceptual structures and language or conceptual structures and each other. You're more likely to have something approaching a unique representation of an idea. At least this is the broad idea. And here, these are the conceptual primitive acts of the original conceptual dependency transframe system, which I'll also call CD. The physical primitives on top there, PTRANS, meaning something's moving, move meaning an animate entity moving one of its body parts, grasp meaning basically that, propel meaning something striking, applying a force, ingest meaning something going inside, expel meaning something going outside. On the bottom there are primitives related to social and mental acts, which don't concern us too much at the moment, but those are also very interesting. One of the main research questions, sorry, let me get rid of that box there. One of the main research questions that we try to address is, do we have the right set of conceptual primitives and connectives, or how much does our primitive decomposition system correspond to the ways that people actually work in doing these kinds of things? Can we bring CD into better alignment with similar systems in the cognitive linguistics community, such as the image schemas system popularized by Lakoff and Johnson? And so in recent work a couple years ago, we found a strong correspondence between the physical primitives of conceptual dependency and these things called image schemas, which, if I were to put it roughly, patterns of spatial and temporal experience that structure understanding. So we found an interesting correspondence between CD primitives and a set of image schemas. Let's take a closer look at a particular aspect of this correspondence, which links the PTRANS CD primitive to the source path goal image schema, and also links the it also links the ingest CD primitive to source path goal and a containment image schema. And this makes a lot of sense if you view the ingest primitive very abstractly as some object being moving or being moved to the inside of another object. Really, it's about movement and about a change in a containment relationship. So it raises a question: could we try to make CD more like image schemas if PTRANS is source path goal, and ingest is source path goal and containment? then maybe we don't really need ingest. Okay. Maybe we can represent all the things that we were using ingest to represent with just PTRANS plus something involving change in containment relationship or a new containment relationship. Now, I don't see a primitive act here in CD that corresponds specifically to change in containment. We'll worry about that a bit later. But this is what we're trying to do. A bit more motivation about this from Shank and the Yale folks. If you do have, they said, we have consistently maintained that an extremely small set of them will, conceptual primitives will account for what needs to be represented in the physical world. And the reason that it is possible to maintain such a position is that the primitive actions combine in fairly complex ways. So they're saying, I think if you do have the opportunity to eliminate a primitive and have it represented as a combination of two or three smaller things or other primitives, furthering decomposition, this is a good thing that will make for a better representation. So we thought, well, okay, we hypothesized about getting rid of ingest and replacing it with PTRANS and containment. What are the ways that we could test that hypothesis? Well, we're fortunate enough that we have a working implementation of the MARGI system, which is the original demonstration of CD and of these kinds of language-free representations. And the MARGI system takes natural language input, and then transforms it to the CD representation, and it's able to generate inferences and natural language paraphrases as output. So maybe we could use this to test our hypothesis or embody this new idea. There's within the MARGI system, there's a subsystem called Babel. I hope I'm pronouncing that right. I don't think Neil Goldman is here to correct, but so Babel is the part of the MARGI system that generates natural language from a non-linguistic language-free conceptual base. It does the translation between conceptual dependency, deep representations, and surface realizations in natural language. And the system has structures that actually represent English in the form of an augmented transition network grammar, and a lexicon. But our focus is going to be on the discrimination net and the conceptual lexicon, or what they call the consexicon parts of Babel. So this discrimination nets, or DNet, DNets are responsible for basically looking at the CD structure, analyzing and interrogating the CD structure, and selecting one or more particular word senses to use to generate a particular to generate a sentence or to generate a phrase. And once a particular word sense is selected, then the consexicon contains this knowledge about where to look in the CD structure to get other parts of the phrase, the sentence that you're about to generate. In most cases, maybe if you've selected a verb, it tells you where to go to get the subject or object of the sentence or part of a prepositional phrase. And so the discrimination net is the part that actually cares about what the conceptual primitives are. So if I'm going to actually change what the conceptual primitives are in CD and also have the system generating things for me, this is where I need to go. Babel has separate discrimination nets for each CD primitive. So if you're trying to say generate an English language realization of a PTRANS primitive act, it'll select the PTRANS discrimination net. If it's ingest, it'll use the ingest discrimination net. So if I want to actually do away with the ingest primitive and try to express all the same things with PTRANS and containment, then I'll need to modify these discrimination nets. I want to like merge the ingest discrimination net with the PTRANS discrimination net, or embed one inside the other, or something like that. Let's take a look at the ingest discrimination net. So the DNets in Babel are trees that are applied to the CD conceptual structure to query it, determine the one or more corresponding word senses that you could use to generate an English phrase or sentence. So there are two kinds of nodes in these DNets. Interior nodes have one or more predicates there, and then leaf nodes have lists of word senses. I'll say more about the predicates in a moment. To remind people, the code that we have for Margie and Babel is demoware from the early 1970s. It's not meant to have a huge coverage, so it's very limited. But it has a few word senses in there. So applying the DNet to the CD structure involves starting at the root node, evaluating the predicates at that root node on the CD structure. If they all evaluate to true, then you go to the true child node. False, go to the false child node. The true child node is actually on the right, and the false child node is on the left in these diagrams. And you can see that the ingest tree mainly cares about the object that's being ingested, the object of the ingest act, except for the case of eat1 down there at the bottom left. Let me show you how the CD diagrams actually look in the code, because the predicate functions in the DNets refer to elements in the conceptual case roles of the CD structure when it's represented as a Lisp S expression. So on the left, the arrow marked with an O there refers to the object case. In the code, it just has object there. The arrow marked D is supposed to be the direction case of the act, and that's represented as to and from in the S expression. And the inside and mouth parts are expressed in a particular way in the code that you can see here. So let's look at the kinds of predicates that are in the DNets that are relevant to the PTRANS and ingest DNets. There's a EQU predicate that asks, is the case role of the CD structure a particular thing? For example, EQU object air. So if the object of the CD act structure is air, then it might lead you to a leaf node for a breathe word sense. Prop asks, does the thing in this case role have a particular property? So for example, there's actually a knowledge base embedded in Babel that has properties for certain objects. If the object that's being ingested is a fluid, then you might be led to the drink word sense. And ID asks, are two case roles the same thing? So a predicate like ID actor object is asking, is the actor of the CD structure the same as the object of the CD structure? In the case of PTRANS, if this were happening in a PTRANS act, then it means that something is transporting itself, and so that might lead you to word senses for go and come in the DNet. And then here's an example of the CD structure that we saw earlier applied to this ingest DNet. So prop object medication. Okay, we're looking at the object there in the structure with the little O and an arrow as banana, and so it would look things up in the knowledge base and say, okay, banana is not a medication, it's not a gas, it's not a fluid. False, false, false. EQU from mouth. Okay, that's actually true. And that'll lead you to the eat leaf node there in the DNet, and so you'd be prepared to generate a sentence using eat. In addition to that, these DNets also have this interesting feature that Goldman called back pointers, and it allows us to continue to, after we reach a leaf node, allows us to continue to traverse the tree, searching for other word senses that might match. And usually what it does is it leads you to more general word senses that are a match. In this case, there's a pointer that also selects a word sense for the verb ingest to generate sentences like Mary ingested a banana. So interestingly, ingest is the name of the conceptual primitive, and then it's also a word sense that you can generate from those ingest primitive acts. All right, so okay, back again. I want to represent ingest acts as PTRANS acts with a change in containment relationship. Okay, let's get back to work on that. All right, so what about the containment relationship thing? Well, classic CD has a contain a predicate that you can put to describe what they call picture producers or objects inside of the CD acts. but it doesn't have change and containment as a primitive act. And there's no trace of this contained predicate in the code. But as we saw just a moment ago, Babel does use inside as a part relationship that it can attach to objects. So what we'll end up doing is model a change and containment relationship using the directive case, using the to and from attributes or cases in the CD structure, and then using inside as a part relationship. And actually, in the code, this is kind of already there in the ingest acts that they already have to and from conceptual cases to specify that Mary is ingesting the banana to the inside, to her inside from her mouth. Is the way they had it. So yeah, this feature is kind of already there in the ingest acts that were given as examples in the code. So I think all I have to do when it comes to the CD structures in this new system is to just replace the act, replace the primitive act ingest with PTRANS, and then it looks like things will be fine. This is easier than I thought. All right, but I still have to worry about the DNet. When you're generating the CD, the DNet is going to analyze the CD structure to figure out what word sense to use, and I need to combine the ingest and PTRANS DNets together. I'm going to try to embed the ingest DNet in the right spot. All right, so we looked at the ingest DNet a moment ago. Let's look at the PTRANS DNet, which is a bit larger, more complicated than the ingest net. I have kind of an abbreviated picture of it here. You can see there are parts that it's too large to fit on the page here, so there are parts that are less interesting to us that are kind of abbreviated, such as generations of go and come there. But there's a particular spot here where I'm going to try to, and you can read more about this in the paper, we're going to try to embed the ingest net. So looking at this figure here, and looking at the predicates here in this abbreviated PTRANS DNet, let's see, actor object, if that's false, that means the actor's not moving itself. I think that would be correct for ingest. Actor not unknown, I think that would be correct for ingest. This part is used for things like, if this were true, it would be used for things like someone taking a ride in a vehicle or something. From case is nil. Okay, this is hard to explain. In parts of this DNet, they sometimes send you over with a false to try generating certain things, and then send you back to the same area, the DNet, using a back pointer. So this is a little bit of a confusing part to the code. Again, this is demoware that wasn't released as open source. But basically down here, where on the bottom right here, where POR1 and STAB1 are, you're starting to see something that has to do with objects sort of moving inside, containment relationships changing, objects moving inside each other. So that's where we'd like to put our entry point for sticking the ingest DNet in there. We took this interior node that has these three predicates in it that was used for STAB1. Sorry for the violence, but these were the word senses that they had in their demo. And then we split it apart so that we have one node here for equal to inside. And that will end up generating from take 3 and move 1. And then down here we have on the right there, we have a node that basically helps us. If it's true, then we'll generate STAB1. If it's false, then it'll be everything else, and that will have EQU to inside to be true if you end up at that end up false from there, from that other node there. So this looks like a good place to embed ingest, because all those other things that turned out being false or true when you got down here, all those other predicates seem to make sense for generating something from ingest. We're going to try to put it here, and so here it is. We changed the structure slightly of the PTRANS PTRANS DNet there at the bottom, and then we basically stuck the entire ingest tree there at that location, basically unmodified. So this appeared to work. Here's some evidence that it did. We ran the Babel system with this new PTRANS DNet in paraphrase mode on a few CD structures. Here were the results. Here now we're using PTRANS, no more ingest, right? And so on the left there you're seeing CD structures as S expressions, and on the right there you're seeing paraphrases that were generated with the Babel system running in paraphrase mode on that structure on the left. And you can see, you know, qualitatively that these paraphrases make sense. With this merging of DNets, we really do seem to get a richer representation. In fact, with this improved DNet, the Babel is now generating new paraphrases of things like drinking and breathing and inhaling, using words like take and move that appear to make sense. And in order to do this, we had to create some back pointer nodes, but these were paraphrases that make sense that weren't possible in the previous implementation that are possible now in our new implementation. So we really do appear to be getting a richer representation system with this. Okay, so wrapping up, we implemented a primitive elimination in Babel, no more ingest, just need PTRANS. Was it successful? Yes, we think so, but I want to hear your thoughts and comments about it. In the future, obviously, there's this other primitive called expel, which is kind of the opposite of ingest, and so we could do the same thing with expel, which representing it as PTRANS and containment, changing containment relationship, but instead something is coming out of the container instead of going in. And same with the move primitive, which appears to be a special case of an animate actor moving a part of their body. Maybe we could just replace it with PTRANS again. And generally, a further unification of conceptual dependency and image schemas promises to be very interesting. Would allow us to be able to use more of the systems that were using conceptual dependency to explore image schemas, cognitive systems, using cognitive systems to explore image schemas. So thanks a lot for your time, and I look forward to your questions and comments.